Here we'll watch Bethany in her second lesson as she continues with the practices we refer to as eliciting students' ideas. The first practice in this set is getting students to share what they know about an interesting science phenomenon or event. We refer to this as eliciting ideas, but this kind of discourse also activates a lot of prior knowledge. The second practice is selecting which of the students' ideas, past experiences, or puzzlements to make part of a public record. And finally, after the lesson is over, the teacher does a quick assessment of how the students talked about the anchoring event and uses that information to adapt further instruction. On the first day of class, Bethany posed a question about the population of hares in a northern forest ecosystem. Students made predictions, and then after reading some basic information about this species, created hypotheses for the up-down pattern they observed in the graph.
What you need to do is go to your group and assign your roles again. And you're going to come to a group decision about the most important factor in your hypothesis. Remember, you can use your disagree and agree kinds of sentences.
A week previous to this unit, Bethany had asked her students how they might refer to one another's ideas. She had them create posters for how to agree with their peers and how to respectfully disagree. These talk skills are important in a classroom where ambitious science teaching is used, because much of the work students do is expressing, challenging, testing, and revising ideas. Not just science ideas, but their own as well.
Record your ideas in your journal and try to label on your poster what you think the most important factor is. So we're gonna, what did you, oh yeah, I wrote anything else.
So,
do we just say poetry?
I wrote down both.
Yeah, I put both at first, but then I thought it should be like the poachers. Well, they're both important, I think. Well, like the poachers affects the predators first before the predators. Yeah, I don't know what I'm talking about.
Names one thing is effective, another one follows, and then chain reaction.
Do a consensus on the
Because when they kill them, there's not as many predators to eat the hares, and that's why the hare's population goes up.
The predators will kill the hares.
Okay.
If there's more than
So the population will decrease, and then that also connects because when the population decreases, they can't reproduce anymore. So it's just going to keep going down.
But don't they reproduce anyway?
Yeah, but they won't have as much stress to reproduce. That makes sense.
Okay, so are we adding or changing something here?
We're not just going to get finished.
Oh, okay, what are we adding?
We're just going to explain why the hare population increases over the time of YD.
Okay, so why does it? Diane?
Because the predator level is high.
Okay, so is that what you're going to graph? So does this graph of the predator show that?
Well, this shows the prey going kind of down, decreasing, and this is the reason why.
Okay, so can you show me on this graph how this graph you drew matches with what I think you just said? Did it say that? What did you say? So as the predator population goes down,
The hare population decreases because they can't hunt the hares. But
okay.
then when it increases, the hares go down.
So I should see if I have the least amount, what I see here is I have a low amount of, what, predator? And a high amount of hares. And then what happens?
Say hi.
What happens next? What goes down? So the hare population goes down, and what happens to the predators? Okay, so why does that happen?
because the predator, there's a lot of predators, so the hares are going to be killed.
Okay, so what's causing what here? Is it the predators causing the hares to change, or the hares causing the predators to change? Or are they like go together? So you guys can talk about that.
Predators cause the hares
Did you say the most important factor? Okay, so you
Because
still
if
think
there's,
that?
it matters on the amount of predators, because if there's more, then it decreases, but if there's less, then it increases.
there's poachers.
So what I'm going to do now is give you a larger model of this data, which shows what happens over a little bit over 35 years. Okay, and I'll put these directions up on the board. But what I want you to do is first start by describing what you see in this graph, and then you're going to see how well your hypothesis or your factor kind of matches this. So we're kind of testing your idea to see how well it goes now with this larger picture. Okay?
When it's high, the food is low. So then it's kind of like rats. So when there's enough food, when there's enough food supply, they're like kind of. But when the food supply comes really low, they start dying. They start losing strength, and then they start dying.
Especially because their lifespan's only 1.5 years. So if they don't have a lot of food, they're going to become really weak.
I think the predators would have been in the exact same line as the hares. Because when they're stabilized, the predators stabilize. When the hares increase, they increase because they have more food. And when the hares decrease, they decrease also because they have less food.
That's without the food.
Only poachers had anything to do with this.
So since there are more predators hunting the hare,
You didn't think things clearly? So why are you thinking that?
Because the poachers, the primary factor, but then it's not can't be because it's like that.
Okay, so why does that mean the poachers couldn't be the primary factor?
Because if the animals would be species, this would have been going up. So this goes down and then start going up again.
So what do you need to do now?
Rethink, think.
Okay.
We're going to get another graph on the predators, possibly.
Oh, that would be great. So that's the next question I was going to ask you is how you could, what you might need to do to test your hypothesis or to get more information. So that could be something that you say that you need. What would that graph help you know?
That would help us know if the population of the predators is going up and down with the hares or opposite to.
Okay. And what would that tell you?
So if it goes up with the hares, that means that the predators aren't affecting the hares that much because they're stable. And then if the poachers are affecting the predators, then we see an opposite or inverse graphs of this.
Okay, so maybe as a group, that's one thing you could work on showing is if, like, you could draw some other graphs that would show what you think the other factors are like. So you can kind of model your hypothesis by showing it on the graph.
It repeats this cycle right here.
so if you was at our little things, we would look like a cool little DNA cell. What do you guys think about this graph?
Well, my prediction was correct.
Well, some of the other groups are thinking the opposite of you. That if there's more hares, then there should be more predators because there's more food. And if there's more predators, then they eat more and then they both fall together. They rise and fall together. What do you think about that? It seems accurate. It could be. It's the opposite of yours.
Both seems right.
So what would you need to know? Like what information would help you? Like if you could go out as a biologist and test this out, what would you do?
Maybe we could like start with like an amount of predators, an amount of hares, and then do it like over an amount of time. And you have to kind of like record how the population of each one goes.
You're saying a safe hunt, then they were reproduced and they weren't hunted. So why were we saying they weren't hunted here? because the predators were chasing other prey. And then what happened here at the top of the graph?
The predators prey migrated or no, like
They migrated and
If we're gonna still go with that story, how could it start going back up?
the predators came.
honestly, other prey were hard to find, so they came after the hares.
That's here. So then what happens
They
here?
probably their main source of food probably came back to them.
Okay, so can you use your hypothesis to tell this whole story?
Oh yeah. Okay, so I think I can tell the story because like over here they're hunting the hares, and over here they're like the predators or their main source of food of the predators.
Yeah,
came
but
back,
the main source of
but
food
it's
doesn't
gonna
go
be
out for a couple of years.
it's gonna be repetitive.
So keep discussing. I need to check with other groups, but you need to decide whether or not this works to explain this.
Piece of choice.
Hey, you good?
Like your main source of food doesn't just go out for a couple of years, because like this graph right here is in years. So that might have been something else.
They could have migrated to a place for 2 years and came back.
All right. So did
I
you
think my
discuss
answer
between
might
you
be
two?
right because like, he doesn't have that much evidence to back it up.
Where's your evidence?
Well, I just showed you the graph. How
I didn't hear you.
Do it again.
Well, I'm asking for evidence about the graph. So you're making claims about the graph. I want to know what evidence you have to make those claims about the graph.
So, let me see your evidence.
What was your claim?
Well, I haven't come up
No,
with a
right?
claim, but I was going
It was
against.
your idea, leader.
I was going against my own idea.
So you're being skeptical.
Yes. My hypothesis was correct, but I'm now disagreeing with it.
Okay. Are you agreeing just to disagree, or do you really think it doesn't work?
Yeah, because you can't just have a main source of food go out for a couple of years. This one we thought that because we didn't have that much evidence to like back it off with. And then we get this graph right here where it's showing us all this right here.
Okay.
And it can't just go out each time for a couple of years and just come back.
So you think it's unlikely that the
It's just,
what?
I don't see how that fits together.
But what part of it do you not think is very likely?
Like right here it goes out, like the food goes out for like, I don't know,
I think it's here's where the food's not available. No, yeah, you're right. Right here, the other food. So yeah, go ahead.
That's like 6 years going down.
Okay. So the food is gone for 6 years, and then
comes back at all of a sudden, and I don't think that happens.
okay.
That's why I'm disagreeing with his name. Now I'm just trying to figure out my own thing.
Okay. What do you think?
Yeah, man. Okay.
Uh-oh, Richard, you have two people who think that this hypothesis doesn't really work now. That we see
Yeah,
the larger
man. What you got, bro?
model. What do you think? Do you understand what they're trying to say?
Yeah.
Which is
About like the how long it takes for the like things to come back. Like the food can be gone for that long.
what do you think about that?
So I think you might be right.
I guess I agree with it.
You
I
guess.
wasn't looking at the years.
Why aren't you sure?
What would the graph look like if your hypothesis were correct, or were like something that you felt like you could support?
I think like it would be like this, but more closer apart. Like it wouldn't take as long.
Okay. And then you'd be able to kind of think that you had enough.
Yeah, but it wouldn't be constantly. That's what I'm trying to think.
Oh, it did end up like a DNA thing, huh?
Well, that's if our hypothesis is
Oh,
correct.
if your hypothesis is
Well,
correct.
we figured out that we would need to get the predators population over the years, and we would need to compare it to the hares. And if the predators population was high when the hares was low, then our hypothesis would be correct.
You do understand, Kevin? Okay. You know what a predator is, right? Someone that hunts the animal. Remember there's like 4 animals that hunt the hare, right? But then one of them doesn't live in the forest. Yeah. One of them, so you can say per year,
Okay, so are we adding?
the population goes up because the coyote is not hunting, and there's only 3 hunters, right? But it doesn't do a very good job of hunting. But then here, what happens here? Yeah, so it does a lot of hunting. Get it? Now can you explain?
So is that what you're graph?
This one, It's only living folks and they didn't really hunting them. But then for this one, because when the coyote come in, they stop hunting them. First one, the predator didn't do anything to affect them. That's why the population increased. But then later on, when the coyote come in, the new predator, they decrease.
Okay. Okay, great.
You notice that the hare population is going down.
It's not like it's going down a lot. It's not like it's going down.
20,000.
It's not like it's going down to 0. It's going down only to 40,000. So you can't really say that.
Okay, see if you can tell the whole story of what you just said here, now with this whole
Going through like an up and down pattern. For like a way.
It's going up and then going down.
So you're
I'm
going
guessing
to
that they're like
how does your hypothesis your explanation?
So hunting and they stop hunting, they migrate back or something. And then the population increases and then they come back and start eating them again.
yeah, just describing could be that because then if the hares are like almost done, they'll have food possibly that they left and waited.
Oh, there's still 40,000 of them. They're not almost gone.
Okay, so
You get it, Kevin? So remember how in here, what happened here?
okay, so you'll start by
It increased because there's not, the predators don't hunt a lot, right? And then it decreased here because a new one comes in and hunts a lot, right? Well, same thing here. What's going on right here when it's going down? I mean when it goes up right here.
Not weird at all.
What happens here?
Not awkward.
Yeah, does the coyote leave then?
Yes.
And then what happens here?
And they come out.
And then what happens here?
They go.
Yeah.
The guy starts a fire every 11 years. It's a tradition.
can you use your
And what does that do?
It kills the trees,
he says no, you say yes. So
which then kills the hares.
It changes the environment, so the hares have to get used to the new environment. And it also gives the predators an advantage because the hares are more easier to spot. I don't know why it has to be the same guy every 22 years.
Yes. He starts off when he's 22, then 33, then 44. Then his son carries on when he's 22, and just keeps going. It's a family tradition.
They mark the same location every year and do it too.
Yep.
Are there other things that happen like every 10 or 11 or 12 years?
After a while, the hare population increases again, and then it goes down again. The guy comes back, goes back up, and then the guy comes back,
Yeah.
goes back up, and then his son comes, and then it'll probably go back down after here.
How could you test your hypothesis to see if it was right? Like what kind of data could you collect or what kind of experiment could you do?
Go in the forest. Wait for 11 years till he comes.
And then do what?
Then ask him how he does it.
So you said something too. What kind of data would you collect to see if this hypothesis is
He
right?
said he's gonna run into the middle of the forest and throw a cigarette at one of the trees.
And then, but that's not collecting data.
It's not collecting. Well, in some way it kind of is, but at the same time it's more like getting yourself into trouble than actually going through and getting data.
This guy hasn't been caught for like 40 something.
So you're wondering about why...
So if you went into the woods and you threw a cigarette out there, let's say you roped off a small bit of the woods and you wouldn't start a huge forest fire, but you went in there and you threw out a cigarette, then what kind of data would you collect from that?
If it really did affect the wildlife.
If it actually ignite whatever is around it.
Did he not come up with it? You guys worked together?
So whether it ignited or the forest floor or the trees? Anything else?
Even if it did, if it did light the fire, then we could check if any of the wildlife was affected by it, like check how many hares are still there right after the fire, and then again come back like when the land starts going back, and then check how many there are again.
I'm pretty sure if it was a wildfire, also the predator population would go down too. I mean, because I'm pretty sure there's no really easy way to dodge a fire that's going towards you, unless you like run through it. But I'm pretty sure they catch on fire or something.
So you're saying that the predator would also be affected by...
It should, if it was a fire.
So if the predator is affected by the fire too, as well as the hare, then does that explanation fit with the up-down cycles here?
Yeah, that actually works, because so like these are the hares and the predators going down, but then as like the rabbit population goes back up, so does the predator. And like maybe like right here, maybe some predators grab food and stuff, but also at the same time there's also that natural fire that happens from the cigarette.
Ask her opinion on the cigarette hypothesis.
So after hearing the hypothesis about the cigarette, what do you think about it? What part?
Well, it makes more sense than anything else we've come up with, so.
What do you guys say?
I don't know. We're confused.
We said a lot of things.
We said a lot of things that don't make sense.
But the cigarette idea makes sense?
Some people who would probably do that, so yeah.
You can be one of us.
What?
Lightning strikes every 10 years.
Do you understand what's lightning?
Lightning strikes every 10 years and then starts a fire. Kills everything.
Because the weather's constant, right?
Yeah, the weather is constant. Wait, no.
Well,
it can be unpredictable.
Yeah, but I mean like the El Niño.
So like,
I think it's the weather, because when it's, you see like how the weather, the El Niño affects the bears' food.
But I don't think the bears are the predators.
bears don't eat
I know, but the bear can eat.
There's a lot of rivers that are in Canada.
No, I'm saying, like if it affects it.
Yeah, I know, that's fine.
I know. If the weather affects the bear, it won't affect also the foxes and
the other predators on the other hand.
Yeah.
That'd be like our kosher idea. See, the predators, not predators. Hares versus predators of predators.
Even before Bethany introduces scientific ideas to students, she sees that they are able to theorize about these complex cycles. These students have activated many previous ideas to do this intellectual work. The range of hypotheses is fascinating. Some students believe the cycles are due exclusively to predators. Some have a theory about alternative prey. And 3 groups include the fertility and mortality of hares as an explanatory factor. In upcoming days, Bethany will engage them further in scientific thinking, asking them whether their hypotheses can explain everything they see in the data, how some of their hypotheses might be tested, and what resources they'll need to further develop their explanations.